Hey folks, 434 absolute values, section 2.7. A, absolute value of x is 6. So what number can you take the absolute value of to get 6? Absolute value of 6 is 6, and also the absolute value of negative 6 is 6. So basically, once you have absolute value bars and you want to get rid of them, you would just say x is equal to positive 6, and x is equal to negative 6. Okay. That was a little confusing. Just go with it for now. So if the absolute value of y is negative 3, you should say, oh, wait a second, absolute value can never be negative. So you would just say, nope, can't do that one. So you would say, I'm looking at what the answer would be, no solution. No solution. And then for part C, where am I? Part C, they give us the absolute value of z is equal to 0. So if we solve it like we did up here, you'd say, okay, z is equal to positive 0 and z is equal to negative 0. And then you go, well, there's no positive 0 or negative 0, it's just 0. So z is equal to 0. Okay. So those are my two answers for part A. Did they give us a nice one? Oh well. 438. So if this was a little weird, yeah, I get it. Let's try 438. That'll be more sense of things. 438. We're solving equations now when there's absolute value. So 2x minus 3 in absolute values minus 4 is equal to 1. Step number 1, get the absolute value bars alone. So let's get rid of that negative 4. Add 4 to both sides. And now you have the absolute value of 2x minus 3 is equal to 5. Okay. Now what we did over here might make more sense. The absolute value of this mess is equal to 5, which means you break it up into two ideas. That means 2x minus 3 is equal to 5, or it means that 2x minus 3 is equal to negative 5. Oh, I see what you did over here now. So if absolute value of x is 6, that means x is equal to 6 or x is equal to negative 6. Okay, so over here it's making sense. Absolute value of this mess, 2x minus 3, is 5. So to get rid of the absolute value bars, so we get them alone, then we say that means what's inside 2x minus 3 is equal to 5, or what's inside 2x minus 3 is equal to negative 5. Okay, I get it. And now we just solve them both. I'll do this one first. So add 3, 2x equals 8, divide both sides by 2, x is 4. That's one answer. And then keep going over here, add 3, 2x equals negative 5 and a positive 3 is a negative 2, divide by 2, x is negative 1. Aha. And so we get two answers. X is either this or it's that. Ta-da! Cool. See? It's all making sense. So the key to this was to get the absolute value bars alone. Once they're alone, just split them up like that. Let's try number 444. Now that this is all making sense. 444 says 3 absolute value 4x minus 5 minus 4 equals 11. So we said earlier, in order to play the game, we need to get the absolute value bars completely alone. Okay, so we need to get rid of that minus 4 and that 3. Let's get rid of that minus 4 first, right? Add 4, add 4. So that's 3 absolute value 4x minus 5 is equal to 15. Got to get the absolute value bars alone. Divide by 3, divide by 3. Absolute value of 4x minus 5 is equal to 5. So far, so good. Excellent. Now that the absolute value bars are alone, I like breaking it up into two ideas. Whatever's inside the absolute value bars, the 4x minus 5 must be equal to either 5, or it must be equal to the opposite, minus 5. So whatever's inside is equal to either 5 or negative 5. Ta-da! Okay, solve this, we're done. Add 5, add 5. Ten over 4, that reduces 5 halves. Okay, there's one answer. And then over here, add 5, add 5. That give me a 0? Divide by 4, divide by 4. 0 over 4. 0 over 4 is just 0. So there's my answers, 5 halves and 0. 2 answers. Okay. So that's all fun and games until 452. Oh, 452. Okay. So I think that was making sense. Now 452, they have absolute values on both sides. Okay, so this one, 3x minus 2 in absolute value bars is equal to 2x minus 3 in absolute value bars. Okay, so either they're both positive or they're both negative, or one's positive, one's negative, one's negative, one's positive. But basically, if you have the situation of absolute value bars equaling each other, it breaks up in two ideas. The 3x minus 2 is equal to 2x minus 3. Just pretend like you don't see the absolute value bars. Or the 3x minus 2 is equal to negative 2x minus 3. So basically, when you have this situation, it breaks up into two situations. Pretend you don't see the absolute value bars. Okay. And then make one of them negative. Okay. So let's solve this one. Let me add 2. So bye-bye, boom, boom, bye-bye, negative 1. 3x minus 2 equals, distribute that minus sign to make it pretty. Okay, let's bring all the x's over, add 2x, so that means add 2, 5x, bye-bye, equals 5. I went a little fast, I know. So we get the answers of 1 and negative 1. Okay. We ready for inequalities with absolute values? Inequalities with absolute values. Okay. Here, let me just write the rule for the inequalities. Let's say we have absolute value of x is less than k. So it's either going to be less than, you can put an equal, less than or equal, it doesn't matter. Or the absolute value of x is greater than k. So this is going to be, I call this the less than, I call this the sandwich situation. So that means you're going to have x between k and negative k. Okay. So if you had absolute value of x less than or equal to k, see, that's a less than situation, so it's basically the sandwich situation. Okay. And now let's say it's the greater than. I called this the, what do I call it? I can't remember what I call it. I think I call it like double switcheroo or something. So if it's x greater than k, so it's going to break up into two ideas with the word or. So the first idea, you pretend like you don't see any absolute value bars, or, I do call it the double switcheroo. Or x is switch, switch. Switch the sign, switch the symbol, switch the sign. Okay. So if you get a situation, so let's put the or equal to. Same thing, basically. So the greater than, so you say, okay, let's pretend I don't see the absolute value bars. And then do the double switcheroo. Switch, switch. Okay. 456 is what we wanted. Absolute value of x is less than 5. That's just this situation right here. Okay. So negative 5 less than x less than 5. Okay. And then, so that's x. So when it's x is between things like that, I wouldn't say negative 5 less than x less than 5. I would say x is between negative 5 and 5. Non-inclusive, non-inclusive. So if you were to graph it, negative 5, 5, x values between the two. So negative 5, comma, 5, parenthesis, parenthesis. 458 says absolute value of x That's not what I wanted. Well, I wrote it down. So that means x between negative 8 and 8. So my final answer would be negative 8 bracket 8. It's just like this one. Just draw the same picture. So okay. Moving on to 460. So you'll see that now that that makes sense, all they do is try and complicate it. So 460, they say 3x minus 3 in absolute value bars is less than or equal to 6. Are the absolute value bars alone? Yes. So that means we could do one of these tricks, right? Where we get, you see how the whole goal of this is to get rid of the absolute value bars. So since it's a less than symbol, that's a sandwich. So 3x minus 3 gets sandwiched in between 6 and negative 6. Aha. So now we're back on familiar grounds, right? There's 3 parts going on. Got to get the x step alone. Add 3, add 3, add 3. Boom, boom, boom. 3x. 6 and 3 is 9. Negative 3. 3. Got to get x alone. Divide everybody by 3. Done. So x is between negative 1 and 3. If you graph it, 0, negative 1, 3, bracket, bracket, everything between. Interval notation, therefore, negative 1 to 3, bracket, bracket. Whew. Okay. So then, let's jump to 468. 468. We have absolute value of x is greater than 3. Ooh, greater than situation. Greater than situation, I got to do the double switcheroo thingy. Okay, so to get rid of those absolute value bars, it's x greater than 3 or double switcheroo x. Switch the symbol, switch the sign. Okay. Let's graph it. There's 0, there's 3, there's negative 3. X value is greater than 3, parenthesis, pointing that way. X value is less than negative 3, parenthesis, pointing that way. Okay, so from negative infinity all the way to negative 3, non-inclusive, non-inclusive, union, this area, parenthesis, 3 to infinity. Oh my, oh my. Ponder that, rewind, watch again. Let's make sense of that. And let's see. Oh gosh, let's try 474. 474. 3x minus 2 greater than 4. Absolute value bars are alone. Okay, it's a greater than. Okay, the greater than is the double switcheroo. So the first thing I write down is that if I don't see, as if I don't see the absolute value bars, and I put the word or, and then I write it with the double switcheroo. Switch the inequality, switch that. Solve, solve. Okay. Divide 3, divide 3, x greater than 2. And then over here, add 2, add 2. I'm going a little fast, no big deal, you can rewind. Let's graph this. 0, negative 2/3 is about right there. 2 is about over here. X value is greater than 2, parenthesis, pointing that way. X value is less than negative 2/3, parenthesis, pointing that way. So from negative infinity to negative 2/3, parenthesis, parenthesis, union from 2 to infinity, parenthesis, to infinity. Oh my lordy, 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 lordy. Okay. And then, oh, okay, cool. So that should get you on your way in 2.7. Oof. Okay, dokie. Have fun with chapter 2. We'll talk about it during the week, I'm sure. Have fun. Have fun. They're little puzzles. Just try and get them all correct.